Everyone, today we'll be doing midterm 1, question 5, cheese on dynamic method selection and casting. So here we have a class cheese, which is a parent class, as we have two other classes, brie that extends cheese, as well as feta, which also extends cheese. So I've written out sort of the relationship between the cheese, brie, and feta class here, where cheese is the parent class, and we have two child classes, brie and feta, that both extend cheese. So jumping straight into the main method, we're going to be instantiating three different objects. So let's start with cheese1. And here we know that the static type is on the left-hand side. So the static type of cheese1 is cheese. And then the dynamic type of cheese is feta. So to make sure that this assignment statement works for declaration and instantiation, we should ask ourselves, is the dynamic type of this object, does it have an is-a relationship with the static type? And so since feta does have an is-a relationship with the cheese parent class, this is good to go, and we don't have any errors. Now, moving on to line 3, we have an object called brie that has static type cheese and dynamic type of brie. And here, brie also has an is-a relationship with cheese, as brie is a child class of the parent class cheese. So this also works. And then the last statement that we have instantiating a new object is line 4, where we have an object called feta with a static type of feta and a dynamic type of feta as well. And since all classes have an is-a relationship with themselves, a static type of feta and a dynamic type of feta is good to go, and we don't have any errors here as well. Great. So now let's move on to the methods that we're running. So first, in line 6, we are calling the admire method by invoking the entire class. So we're calling the admire method using the capital C cheese class. And basically what we're looking for here is a static method, right? One that belongs to an entire class, because we're not invoking the method using an instance. And so when going up to the cheese class, we notice that we do have an admire method, but it does not have the static keyword. And that static keyword is necessary in order to call a method by using cheese.admire. So this would result in a compiler error. And note that we haven't used dynamic method selection yet. We only use dynamic method selection when we're dealing with instance methods. That is, we're calling a method using an instance of an object. And since in line 6, we're calling the admire method using the general cheese class, we don't use dynamic method selection for that line. Moving on to line 7, now we're finally invoking an instance method by calling admire method that takes in cheese1 as its parameter, and we're invoking the method using the cheese1 object. So starting off, we know that the dynamic or the static type of cheese1 is cheese. So we're first going to check the cheese class for an admire method that takes in a cheese object. So we're using the static type of this parameter, and the static type of cheese1 is cheese. So once again, we're looking in the cheese class for an admire method that takes in a cheese object as its parameter. So up here we do find it. We find a method that's called admire that takes in cheese as its parameter. So during compile time, we're going to save this method signature. So we have public void admire cheese. So the next step in dynamic method selection is to look at the dynamic type of cheese1, which as we see here is feta. So now we're going to look in the feta class for an admire method that also takes in a cheese. So we're going to be looking for a method, again in the feta class, that matches the method signature as what we've saved during compile time. So as we look in the feta class, we'll notice that we do see a method that takes in cheese as its parameter. And so therefore, we're going to run this method in line 12 because we found a method during runtime that matches the method signature as what we've saved during compile time. So as you see here, going into the body of this method, we're simply just going to print out EEE. All right, so moving on to the next question, we have feta.admire feta. So again, the static type of feta, which is found here, is feta. So we're going to look in the feta class for a method called admire that takes in a feta object. So when we check the feta class, we find that we do have an admire method that takes in a feta object as its parameter. And we're going to save this method signature during compile time. And now we see that the dynamic type of feta is also a feta class. And so therefore, since the static and dynamic type is the same, we simply just run this method. Inside the method, we're going to print out huh. Right. So moving on to the next line, we see that we're encountering a cast here. And as a quick reminder, casting an object tells the compiler what to consider the static type of that object is when going through dynamic method selection. So there are a couple rules associated with cast. So whenever we see a cast, we should make sure that there won't be any errors here. So we're seeing that we're downcasting cheese one to a feta type. And so the first thing that we should make sure of is that there is a parent-child relationship between the cast type and the static type of cheese one. So as we can see here, the cast type is feta, and then looking at the static type of cheese one, we have cheese. And so do we have a parent-child relationship between cheese and feta? We do, right? Cheese is the parent class of feta. Moving on to runtime, we should ensure that the dynamic type of the object is a child of the cast type or is the same as the cast type. So here we see, again, the cast type is feta. And now the dynamic type of cheese one is feta. And so since the cast type and the dynamic type of the object that we're casting to is exactly the same, we also clear runtime for this cast. And so this cast works out fine. And to denote that this cast works, we're going to write feta above cheese one, just to remind ourselves that the compiler is going to consider cheese one's static type to be feta temporarily. All right, so our first step again is to look in the static type of cheese one for an admire method that takes in feta. So going up to the feta class, we're going to then look for an admire method that takes in feta, which we do find right here. So during compile time, we're going to save this method signature. Then moving on to runtime, we're checking the dynamic type of cheese one, which is also feta. And since the static type and the dynamic type are the same, we'll simply run the method that we found during compile time. And we're going to print out huh. All right, and now I'm going to remove the cast because again, these casts are temporary. The next line that we run is feta.admire brie. So again, we're going to look in the static type of feta, and it's feta. We're going to look in the feta class for an admire method that takes in a cheese object. Because again, we're looking at the static type of the parameters that are being passed in. So since the static type of brie is cheese, we're going to look in the feta class for an admire method that takes in a cheese object. And we do find that right here, an admire method that takes in a cheese object. So we're going to save this method signature during compile time. And then now we're going to look at the dynamic type of feta, which again is the same as the static type, Right here, we see that the dynamic type of feta is the same as its static type. So we're just going to run this method that we found during compile time and print out EEE. All right, last one. Here we're running, we are first casting cheese1 to the brie type, and then we're trying to call brie.admire. So same as the previous cast, we should first make sure that this cast is valid. And here you can see we're trying to downcast cheese1 to be of brie, or we're just trying to cast cheese1 to be of type brie. So again, during compile time for casts, we want to check that there's a parent-child relationship between the cast type and the static type of the object that we're casting to, or they could be the same. And so the cast type here is brie, and the static type of cheese1 is cheese. And so again, is there a parent-child relationship between cheese and brie? Well, up here we do, right? Cheese is the parent class of brie, which is the child class. So this cast clears compile time. And now we're going to look at runtime. We're going to make sure that the dynamic type of the object is a child of the cast type. And if not, seeing if they are the same type. So the cast type here is brie. And looking at the dynamic type of cheese1, we have feta. So going up here, looking at the relationship between the brie and the feta class, we find that they are actually what we call sibling classes, right? Where they extend the same class, but they do not have really any direct relationship to each other. And the thing with the sibling class is that they don't have a parent-child relationship with each other, and they're not considered the same class. So therefore, this cast would fail at runtime, and we would have a runtime error. All right, and this was question 5 for summer 2021's midterm 1.